Now this is a slightly more complex determination of orders of reaction. What we have here is A and B going to product, initial concentrations of A and initial rate for 3 runs. Now we can determine the order with respect to A relatively straightforwardly, because you can see if we compare runs 1 and 2, you can see that the concentration of A doubles and the concentration of B is constant. You can also see that the rate doubles. So therefore it's first order, nice and straightforward. Rate is proportional to concentration of A to the power 1. Double the concentration of A and the rate of reaction doubles. So that's nice and straightforward. So we know it's first order with respect to A. But when we try and look at B, you will notice that we change the concentration of B, but we also change the concentration of A. So we haven't got a situation where we're keeping the concentration of that constant and doubling the concentration. Slight problem there. What we need to do is to take into account that we know the order with respect to A already. So if we now compare runs 2 and 3, we double concentration of A, and we also double concentration of B. Okay, so doubling concentration, and you'll notice that the rate of reaction from 2 to 8, in other words, it increases by a factor of 4. Now we know that if the concentration of A is doubled, because it's first order with respect to A, the rate doubles. So in other words, the rate increases from 2 to 4. Due to A. Now, therefore, if we change the concentration of B, the rate therefore now goes from 4 to its final value, 4 to 8. In other words, it doubles. So therefore it must be first order with respect to B as well. Okay? And you will notice that makes a certain amount of sense, because if we look at our values again and we compare runs 2 and 3, we are finding that if we're getting a quadrupling in the rate of reaction by a doubling of both A and B. Therefore it must be second order overall. If we know already that it's first order with respect to A, it must be first order with respect to B as well. So our overall rate expression, rate equals K concentration of A, concentration of B.